Welcome to Projectiles. Second time round. This time hopefully the sound is working, because I forgot to check the last time. We're going to just do it with a few examples. Time to impact, and this is the one on the right that I've already drawn, which is just something projected horizontally off a 20-metre cliff, and it is controlled by the height. Nothing to do with the horizontal velocity, it's just controlled by the height. So u equals 0, a equals minus 9.8, s equals minus 20, t equals don't know, s equals ut plus a half at squared, so that minus 20 equals 0 minus 4.9 t squared, t equals 2.02 seconds. And the range we need to calculate, which is the horizontal distance. That's the normal word used to describe the horizontal distance of any projectile. Doesn't matter what the situation. Don't forget, horizontal is at constant speed. Okay, so constant speed when you're talking horizontal. So because it's a constant speed, velocity equals distance on time, or d equals vt equals the original 5 times the new time, which is 10.1 meters. C, final velocity. So the final velocity is made up of two parts, because when something lands, as you can see on the one on the angle above, when something lands, it lands at an angle, and that angle is v final. But that angle is made up of the vertical speed and the horizontal speed. The horizontal speed we know is 5. We also need an angle final if we're going to do that. So this is where we're going to calculate the vertical right now. U equals 0, a equals minus 9.8, s equals minus 20, and v equals don't know. V squared equals u squared plus 2as, so that works out to v equals 19.8 ms to minus 1. So 19.8. So that, using a very traditional Pythagoras, v final equals the square root of 19.8 squared plus 5 squared. So v final equals 20.4 meters per second minus 1, and tan theta equals 19.8 over 5. Theta equals 75.8 degrees. So that takes care of the first half. The second half, we're going to do a very quick one with a projectile at an angle. For example, we've got the ground along here, and something is projected at 20 ms minus 1 at 30 degrees. Think about the fact that, I'll break that vector down, 20, we'll change colours. It's always a good idea to separate the colours if you've got them available. U horizontal, 30 degrees, and this is breaking them into components, U vertical. So A, initial vertical component, and B, initial horizontal component. So U vertical equals 20 sine 30 degrees equals 10. U horizontal equals 20 cos 30 degrees equals 17.3 ms to minus 1. C. Flight time. As was explained today, because this is like something being thrown straight up and straight down, so it's going up at 10. So U equals 10, V equals minus 10 when it hits the ground again, A equals minus 9.8, T equals don't know, V equals U plus AT, minus 10 equals 10 minus 9.8T, T equals 2.04 seconds. And the last one, second last one, sorry, maximum height, and E will be the range, which we know is the horizontal distance. Okay, so let's just finish off. U equals 10, V equals 0, A equals minus 9.8, S equals, and that's just a V squared equals U squared plus 2AS, so that 0 equals 10 squared minus 19.6S, S equals 5.1 meters, and the last one, range, constant horizontal velocity, which was the original component. So range just equals U horizontal times the flight time. So 17.3 times 2.04 equals 35.3 meters. So that it should be a quick summary of how we do it. Hopefully it is also a summary with sound instead of without sound.